Hi class, it's Mrs. Pemberton, and today this is a little help with page 85 and 86 in your homework. We are going to start with page 85, and let's see here, let me grab my pen, there we go. And in the example, we are given a function here, and it gives us the graph. We want to go ahead and complete this table. So go plug in -1, do the math, and out comes 1. Plug in 0, do the math, out comes 2. Plug in 1. And plug in 2, and you get 5. Oops, excuse me, 4. Let me erase that real quick. So you'll get 4 here. Alright, so go ahead and circle your initial value. When x is 0, your y is 2. You see your initial value right here in your equation and right here in your graph. When x is 0, that's your initial value of 2. Okay? So if you read this question, number 1, here's your initial value, 0, 2. Now the rate of change, go look at how much each time that y is increasing, and it's increasing by 1. So m, our rate of change, is going to be 1. Looking at the next question, it's asking you which form is it written in? Well, it's going to be this form right here because we have something being added to it that's not 0. We're adding 2. So we would say that it's in this form. And in this case, our y-intercept, or our initial value, is 2, and our rate of change is 1. So you could write it like that. Okay? The same thing as seeing it like this. It doesn't change a number if we go times 1. Cool. Next one, looking at x squared, that makes it a nonlinear function because we're going to have a different rate of change. It's not going to be consistent. Okay, I'm going to scroll to the next page here. And on the next page, number 4, you see that you have 2 different functions. So go ahead and create a table, and you can plug in some x values, like 0. So I'll go plug in 0, do the math, out comes 2. And I'll graph that point, 0, 2. And you see that right there, that's our initial value. Plug in 1, and we'll do the math, and out comes 4. So we'll graph that point, 1, 4. Plug in -1, and we'll do that math, and out comes 0. So -1, 0. I'm going to try to draw a straight line here. It's really tough with this, though, so that's pretty straight. And on the next one, let me change colors here. So on this one, we see that our x is squared. Okay, so we're going to plug in 0, and we'll square it and add 2. Out comes 2, and we'll graph that point. Plug in 1. I'm just picking nice, easy numbers to plug in, so that's 1 plus 2 gives us 3. So 1 and 3. Plug in -1. Okay, so when I square -1, that gives me 1 plus 2 also gives me 3. So I no longer have a constant rate of change, and I'll graph that point. I end up with a U shape, so that's nonlinear. Number 5, which of these equations are linear functions that go through 0, 6? Explain your reasoning. So right away I know this one's not it, because it's not linear. It has something squared. These next ones are linear, but we want to see if they go through 0, 6. So I'm checking to see if when I plug in 0 for the x, does y come out as 6? So let's try it. 6 times 0 is 0, not 6. That one's out. Plug in 0 here, 0 plus 6. Yeah, that one works. I get 6 for the y. That one works. And if I try it here and add 6, that's 0 plus 6. Yeah, that one works as well. And then on the last one here, so we're looking at the graph, and right away we see it's linear. And I also see that there's the initial value. So I know it's going to be a plus 3 at the end. And now I just have to find the number that goes in front of x. I need to find my rate of change. And if I look, I can pick any points on this graph, and I can count. So I go up 1.5 for every x. Go up another 1.5 for every x. So that's my slope. I'm going to go up 1.5 each time. That's my rate of change. hopefully this is helpful to you.